If we have a straight line, then the normal to that line is a line that is perpendicular. If this line has a slope a, then the directional vector for that one is 1a. And then we know that the directional vector for this one and slope of this one is minus 1 over a. So that's the slope. And the directional vector for that one is so like this. This can be proven by using scalar product or dot product. Okay, so let's do a proof. We have that this slope is a, which means that the directional vector for that one is 1a. Let's call the slope of this one for b. Then the directional vector for that one is 1b. Since these are perpendicular, we know that the dot product of those two is equal to 0. Then if you multiply these now, we have 1 times 1, a times b, that should be equal to 0. Then we have a times b is equal to 1, but minus 1 on this side. But this just gives us that b is equal to minus 1 over a. And that was what we wanted to prove. And if this is equal to that, then we know that the directional vector for this one is 1b. So that must be 1 minus 1 over a. For example, what is the normal to this straight line? 2x minus 3. Here we have that the slope is 2. So the slope for the normal is 1 over a. So that's this. So this is the slope for the normal. Another example, let us consider this straight line. Now we want to find a normal to this line that goes through the origin. To a straight line there are infinitely many normals. So we want to find that one that will go through the origin. So let's call this one ax b. First of all, we know that this normal have a slope of minus 1 over 3, since this was the slope of that one, and they are normal. So we know the line is minus 1/3 x plus b. We only need to solve b. But if it goes through the origin, we know that b must be equal to 0. So this is minus 1/3 x. So this is the equation or formula for the straight line that goes through the origin, which is a normal to our line.